This is the video for page 427, 41 to 89 every other odd, and you guys are doing 42 to 90 every other even. Okay, so you're multiplying like bases. If you multiply like bases, you add the exponents. So we're going to do 2/3 plus 5/3. We already have a common denominator of 3, so then you just do 2 plus 5 is 7. So this is going to be a to the 7/3. And let's see how they ask us to write it. It says use the property of exponents to simplify each expression. Write with positive exponents. Okay? So a to the 7/3 is as far as we need to go. If they asked for it in radical form, we would just swing the denominator around front. It would be cube root of a to the 7th. Okay? Like bases, so you add the exponents. So it's 1/4 plus 3/8. We need a common denominator. In this one, my common denominator is going to be 8. So you say 4 goes into 8 2 times. 2 times 1 is 2. And then over here, 8 goes into 8 1 time. 1 times 3 is 3. Now that I have a common denominator, just add the numerators. 2 plus 3 is 5. So it's going to be 3 to the 5/8 power. And that's as far as you need to go. Okay? Power or exponent rules say if you have a power outside, you need to give it to both pieces. So this is going to become 4 to the 3/2 power times u squared to the 3/2 power. Okay? So 4 to the 3/2 power, if I bring this around front, I get the square root of 4 cubed times, and then back here, if you take a power to a power, you multiply them. So this is going to become u, and then when you multiply fractions, you multiply straight across. So this becomes 6/2, which we know is 3. So it's u cubed. Now over here, we've got the square root of 4 cubed. You can do this one of two ways. You can either say 4 cubed is 64, and then the square root of 64 is 8, so it ends up being 8u cubed, or you could have said the square root of 4 is 2, 2 cubed is 8. Either way, you'll get to the same answer. Alright, first things first, I'm going to give this 1/2, so it's x to the 3/1 to the 1/2. So when you take a power to a power, you multiply the exponents. When you multiply fractions, you just multiply straight across. So it's 3/2. So you have x to the 3/2 over x to the 7/2. When you're dividing like bases, you subtract exponents. So this would be x to the 3/2 minus 7/2. Since they have a common denominator already of 2, you can just do 3 minus 7 is -4. -4/2 is -2. And if you have a negative exponent, you have to drop it like it's hot. So this becomes 1/x squared. Okay, remember, the directions said you have to end with a positive exponent. This is not a positive exponent, so you have to drop it like it's hot before you can go to the next one. Alright, so here I've got each piece of the numerator needs this 1/6, so it's going to be y cubed to the 1/6 times z to the 1/6 all over y to the -1/2 z to the 1/3. Okay, so the first thing I'm going to do is multiply 3 and 1/6. So if I've got 3/1 times 1/6, remember you multiply straight across, it's going to become 3/6, which we know is 1/2. So this is y to the 1/2 z to the 1/6 over y to the -1/2 z to the 1/3. So if you're dividing like bases, you subtract the exponents. So we've got y to the 1/2 minus -1/2 z to the 1/6 minus 1/3. So add a line, change the sign. This is going to become y to the 2 halves, okay, because you have a common denominator of 2, and there we go. So if you have a common denominator of 2, you just write the 2, and then you say 1 plus 1 is 2. And then z, so we need a common denominator of 6. So we know this one's going to stay the same. 3 goes into 6 2 times. 2 times 1 is 2. So my common denominator is going to be 6. 1 minus 2 is negative 1. So to clean this up a little bit, y to the 2 over 2 is just y to the first power. And then z to the negative 1/6 needs to go to the denominator. So your final answer will be y over z to the 1/6. Everything has a positive exponent. And so you're good, you're done. Okay? So we're going to distribute y to the 1/2. So that means y to the 1/2 times y to the 1/2 minus y to the 1/2 times y to the 2/3. Okay? If you're multiplying like bases, you add the exponents. So this becomes y to the 1/2 plus 1/2 minus y to the 1/2 plus 2/3. So this becomes y, my common denominator is 2. And so I'm just going to say 1 plus 1 is 2. Minus, over here, I need a common denominator of 6. 2 goes into 6 3 times. 3 times 1 is 3. 3 goes into 6 2 times. 2 times 2 is 4. So this is going to become y, my common denominator is 6, and then add your numerators to get 7. So my final answer is y to the first power minus y to the 7/6. And you can't take that any further because those are not like terms. Okay, so now we're going to double distribute it. So we'll distribute that, and this and this. So first I've got 2x to the 1/3 times 2x to the 1/3. And then next is minus 3 times 2x to the 1/3. And then plus 3 times 2x to the 1/3. And then minus 9. Okay, so let's deal with each piece. So this is going to become 4x. If you're multiplying like bases, you add the exponents. So my common denominator is going to be 3, because they both have a 3. So you do 1 plus 1 is 2. So that's 4x to the 2/3. Minus 6x to the 1/3 if you multiply these. Plus 6x to the 1/3 if you multiply these. Minus 9. These actually cancel each other out. So you're left with 4x to the 2/3 minus 9. It's almost a difference of squares, but the 2/3 messes us up, so we can't go any further. Alright. Factor the common factor from the given expression. Okay, so they want us to factor an x to the 1/5 out of both of these. So what that means is we're going to be dividing. So what we're going to do is we're going to do x to the 2/5 over x to the 1/5 minus 3x to the 1/5 over x to the 1/5. Because when you're factoring, you divide. So these actually cancel each other out, so that's easy. But here, you have like bases, so you subtract the exponents. So it's going to be x to the 2/5 minus 1/5, and then all minus 3. So x, 5 is our common denominator, so 2 minus 1 is 1. So it's x to the 1/5 minus 3. And remember, when you write this, because you factored out an x to the 1/5, that needs to be in the front. So this will actually be your final answer. And then if we were to distribute that back in, we would get this. Okay? So 73 says, use rational exponents to simplify each radical. Assume that all variables represent positive numbers. Okay, so they want radical notation. So the first thing I'm going to do is take this index back and make it my denominator. So it's going to be x to the 3/6, which if I reduce becomes x to the 1/2. But they want it in radical notation. So I need to bring the 2 back around front and add my radical again. So the simplified form is the square root of x to the first, which is just the square root of x. Okay? Now same thing here. But the first thing I'm going to do is break this up. The fourth root of 16 times the fourth root of x squared. Well, the fourth root of 16 is just 2. So we can get rid of that. And here I'm going to take the index back and make it my denominator. So this is going to give me x to the 2/4, which is the same as 2 times x to the 1/2. But they want it in radical notation, so you need to bring this 2 back around the front, make it my index, add my radical. So then you have 2 square root of x to the first power, but we don't need to write that. Okay? So the first thing we're going to do here is we're going to take this 12 and we're going to take it to the back and make it the denominator of both. So this becomes a to the 8/12, b to the 4/12. So if I reduce this, I get a to the 2/3 because they both have 4 in common, b to the 1/3 because they both have 4 in common. Now, because both of these indexes are 3, when I swing it around front, I can keep it together. So look, you can look at it this way. First do cube root of a squared. So that's if I whip this 3 around front and then add my square root, and then whip this 3 around front and add my root. So it's going to be times cube root of b to the first power. Because these both have the same index, you can multiply them together. So it would be the cube root of a squared b. Alright, if you want to skip this step here and you see that they're both 3 and just pull it out front, you're welcome to do that. Okay, so I have the cube root of y times 5th root of y squared. So if I take this to the back and make it my denominator, so remember this is to the first power, so it becomes y to the 1/3, you get rid of the radical, swing this around back, times y to the 2/5. If you're multiplying like bases, you add the exponents, so it's going to become y to the, and the common denominator of 15. 3 goes into 15 5 times. 5 times 1 is 5. 5 goes into 15 3 times. 3 times 2 is 6. So this becomes y to the 11/15, but they want it in radical notation. So swing that 15 back around front, write your radical, so it's 15th root of y to the 11th. Alright, last one. Okay, swing this around back, swing this around back, swing this around back. So it becomes x to the 1/3, because remember it's an assumed 1 here, times x to the 1/4, times x to the 3/8. So this is going to become x to the, if you're multiplying like bases, you add the exponents. You need a common denominator. It's going to be 24. So 3 goes into 24 8 times. 8 times 1 is 8. 4 goes into 24 6 times. 6 times 1 is 6. 8 goes into 24 3 times. 3 times 3 is 9. So this becomes x. 24 is your common denominator. Let's just say 8 plus 6 plus 9. is 8 plus 6 is 14, and 9 is 23. So it's y to the 23/24. However, they want it in radical notation, so bring that denominator out to the front and draw your radical sign, which is 24th root of x to the 23rd. And that is your final answer. That's it, guys. Have a good night, and I'll see you tomorrow.